Imagine a world where the moon holds the key to understanding our planet's origins and powering our future. For years, China's space program has been quietly revolutionizing lunar exploration, sending robotic explorers to unearth secrets buried in the moon's ancient rocks. From bizarre geological findings to potential energy sources, their discoveries are rewriting what we thought we knew about our celestial neighbor. Let's dive into this cosmic journey and explore what China's missions have uncovered. The moon isn't just Earth's glowing companion, it's an anomaly. Compared to other planets, Earth's relationship with its moon is strange. Venus, our closest planetary cousin in size, has no moon. Mars has two tiny moons, Phobos and Deimos, barely larger than asteroids at 22 km and 12 km wide. Gas giants like Jupiter boast massive moons, but their planets dwarf Earth by hundreds of times in mass. Yet our moon is roughly the same size as Jupiter's largest moons, making Earth's setup a cosmic oddity. Why is our moon so large relative to Earth? Scientists are still piecing together this puzzle, and China's lunar missions are providing critical clues. Decades ago, Apollo astronauts returned with lunar rocks that shocked researchers. They were chemically identical to Earth's. This suggested the Earth and Moon didn't form separately but share a dramatic origin. The leading hypothesis, dubbed the Great Impact, posits that 4.5 billion years ago, a Mars-sized planet smashed into the young Earth. This collision melted both bodies, flinging molten Earth material into space, which coalesced into the Moon. Recent supercomputer simulations, running millions of scenarios, have refined this model, confirming it matches the Earth-Moon system we see today. The Moon, in essence, is a fragment of Earth, sculpted by a cataclysmic event. Since 2013, China's National Space Administration has spearheaded lunar exploration with a series of Chang'e missions, named after the Chinese moon goddess. These robotic probes have ventured where no human has, targeting the moon's most enigmatic regions. Unlike NASA's Apollo missions, which focused on equatorial plains, China's uncrewed landers can tackle rugged terrain, delivering groundbreaking insights into the moon's history and composition. In 2019, the Chang'e 4 mission made history by landing on the moon's far side, the hemisphere that never faces Earth, often mislabeled the dark side. This region gets ample sunlight but remains hidden from our view. Unlike the near side marked by dark volcanic plains, the far side is a rugged expanse of craters with few volcanic traces. Why the difference? Chang'e 4 rover, Yudu-2, explored the 180 km wide Von Karman crater, nestled within the massive South Pole Lake and Basin, a 500 km wide scar nearly as old as the moon itself. This basin, formed 4 billion years ago, exposed deep lunar crust, offering a window into the moon's interior. Yudu-2 discovered rocks from the lunar mantle, a semi-solid layer between the crust and core, never seen in Apollo samples. This finding hinted at a more complex geological history than previously thought. In 2021, the rover also sparked intrigue with a distant photo of a cube-shaped object, briefly fueling speculation of alien structures. Closer inspection revealed it was just a rock, its angular appearance a trick of light and low-resolution imaging. In 2024, Chang'e 6 returned the first-ever samples from the far side, collected from the South Pole Lake and Basin. These rocks and dust were strikingly different from near-side samples. They were lighter, stickier, and lumpier, with less volcanic material. Surprisingly, the volcanic rocks found were younger than expected, averaging 2.8 billion years old, with one fragment dating back 4.2 billion years, the oldest lunar rock ever found. This suggests the far side remained molten longer than thought, challenging the idea that it cooled quickly due to its distance from a hot, young Earth. The near side, familiar from Apollo's equatorial landings, covers just a fraction of the moon's surface, equivalent to a small city. These missions miss the moon's more dynamic regions. Enter Chang'e 5, which in 2020 targeted the Rumker Dome, a volcanic feature in the near side's northwest. Unlike Earth's explosive volcanoes, lunar volcanoes ooze lava over millennia, forming flat, wide domes. Chang'e 5 samples included the youngest lunar rock ever found, at 2 billion years old, proving the moon was geologically active far longer than suspected. Among Chang'e 5 haul was a never-before-seen mineral dubbed chang'e. This transparent, colorless crystal, tinier than a hair, contained helium-3, a rare isotope deposited by solar winds. Earth's magnetic field blocks solar winds, leaving us with scant helium-3, but the moon's surface is rich in it. Helium-3 could fuel future nuclear fusion reactors, offering clean, radiation-free energy. While fusion technology remains elusive, this disco very underscores the moon's potential as a resource hub. Chang'e 5 also found water in an unexpected place. The volcanic soils of the Runker Dome, not just hydrogen and oxygen, but actual H2O molecules, locked in a hydrated mineral called Ohm-1. This suggests water is more widespread on the moon than previously thought, not confined to shadowy craters. For future lunar bases, this is a game changer, as water supports life and fuel production, making moon colonization more feasible. China's findings are reshaping our understanding of the moon's formation and evolution. The prolonged volcanic activity in mantle rocks challenge the Great Impact theory, suggesting the moon's history is more intricate than a single collision. These discoveries also illuminate Earth's own origins, as the moon's story is intertwined with ours. Looking ahead, China's missions are laying the groundwork for lunar habitation. By mapping resources like water and helium-3, they're paving the way for sustainable moon bases, a stepping stone to deeper space exploration. China's lunar missions have transformed the moon from a distant enigma to a treasure trove of scientific and practical potential. From mantle rocks to helium-3 crystals, each discovery peels back layers of cosmic history while pointing to a future where the moon powers and sustains humanity's ambitions. As China continues to lead lunar exploration, the moon's secrets are becoming our own, guiding us toward a new era of discovery.